In this video, you will see Julian and Alyssa watch an animation of two toy cars racing. The blue car accelerates, and the red car travels at a constant speed. The blue car passes the red car 5 seconds after they start. Julian and Alyssa will try to determine the average speed of the blue car over the 5-second interval. As they work, consider the understandings they express and determine if their reasoning is valid.
I mean, when I think of like average, I think of like adding up all the different possible. So in this case, it'd be all the different speeds over the amount of speeds, but like I feel like we'd have like at each moment in time, like there's infinite amount, like between 0 and 5. So we'd have infinite amount of speeds, like with the decimals, but then you can't divide by infinite either to be infinite or infinity.
So then should we just pick should we just go from like 0 to 5 and just like all the integers, so like do like 0, 1, 2, like instead, like to lower the number of things we're looking at?
You do a table. So like 0, 1, 3, 4, 5.
Yeah.
And then the distances.
Yeah. And so we know that the blue car travels, like we can follow this formula here, like t equals 2.8 t squared.
Okay, so then we need velocity. So what velocity is distance over time.
Mm-hmm.
So well, we know that we're starting at time 0, so our velocity should be 0. And then
would we just add them all up and then divide by how many seconds we have? So like 6 seconds?
Yeah. So
7 inches per second.
I think, I'm not sure if that's right.
Because if we were to do, let's see this one. So like if this is the blue car, if we were to like look at the red car, we know it's constant. And if we know that the blue car passes the red car 5 seconds after, we know that
at 5
seconds they were at the same position. So then if the blue car is at 5 seconds, a distance of 70 inches away from the starting point, then we know the red car would just be 70 divided by 5, and that's 14. But we know that the red car is constant, and the blue car is not constant. So I don't know if that's correct, because we have like this here.
Oh, and you're saying like this would be the average speed of the red car, and we're only having that one.
Yeah. So I'm not sure if that's correct. So like instead of like adding these up and then dividing it, what if we kind of like a slope thing here? So like take like
you mean
y2 minus y1.
Like they change in y over change of x.
Yeah.
So change in distance over change in time. Okay.
So then if we did, let's do 5 and 4. So we would have 7 minus 44.8 all over 5 minus 4, and that's 25.2 over 1 inches per second.
So you think maybe doing
not for all of them?
All of them, and then what, averaging those?
Maybe.
Okay. It just seems weird, like if our velocity is increasing the whole time, like it's changing. So how could we find an average? Because the average speed would be a constant speed. So it seems weird to have it changing, but then decide that the average speed is constant, if that makes any sense.
Yeah.
In this video, Julian and Alyssa tried several different methods for computing the average speed of the accelerating car, but ended up being dissatisfied with their answer. We'll explore how to think about this problem in upcoming videos.